Firefighting used to consist of passing water buckets hand to hand. The first fire hoses of the 1600s were made of leather, but these hoses were heavy, would crack when dry, and often break open under pressure. Modern firefighting began with the lightweight cotton fire hose, lined with rubber to keep the cotton dry and flexible. Fire hoses come in a range of sizes to fulfill a range of functions, from small, lightweight ones for fighting forest fires to large, heavy-duty hoses for industrial fires. Production begins with hundreds of bobbins of polyester yarn, feeding automated looms a floor above. A series of spring rods keeps the yarns under uniform tension. This is essential to create a tight weave. The factory programs each loom to weave specific patterns which incorporate identifier stripes. This is a visual guide to help workers assemble the fire hose later on. This woven fabric will form the fire hose's exterior called the jacket. It's got to weather some nasty conditions, so they soak it in a plastic polymer solution with dye for color. The liquid encapsulates the fibers, making them durable and water resistant. At another station, they mix granules of polyurethane, a form of plastic, with white colorant and adhesive pellets. This mixture is for making the waterproof tubing that forms the inside of the fire hose. When they activate the adhesive in the mixture with heat, this tubing will bond to the hose jacket fabric. The mixer feeds the ingredients to an extruder, which melts the mixture and forms it into a hollow tube. The tube then passes through a basin of cool water to set the plastic. Next, the tube goes to the inspection table, where an automated printer prints code numbers on it for tracking purposes. To assemble the fire hose, they first pull out an outer hose jacket over a 33-yard long cable. Then, with another cable, they feed a second untreated hose jacket inside the first one. Finally, they attach a cable to the third and innermost layer, the tube, and pull it along the entire length of the double jacket. Once it's all the way through, they trim both ends. The three layers, outer jacket, inner jacket, and tube, are now ready to become one. They begin the fusing process by clamping one end of the assembled hose to a steam nozzle. As the clamp holds the hose steady, the nozzle blasts pressurized steam into the tube. At the same time, it moves backward, pulling out any kinks. The hot steam melts the adhesive in the tube material, and it penetrates the inner jacket around it. Once everything's perfectly straight, they pump in cold air to solidify the adhesive. This permanently bonds the layers. They roll up the finished hose into a coil, controlling the winder with a foot pedal. Then they lay the coiled hose on a table to install the couplings. Those are the components that attach the hose to the water supply on one end and to the spray nozzle on the other. They trim each end and then insert a brass expansion ring and then an aluminum coupling on top. An expansion machine does the rest. They attach the end securely to the machine's protruding bar. Then the bar retracts and expands, pushing the brass ring outward. The force wedges the brass into the aluminum coupling permanently. This company tests every fire hose it produces under high pressure on this table. After marking the type of hose with a stencil and indelible ink, they fill the hose with water. They check for holes and kinks and verify that the couplings stay in place. After the test, they drain the water. They insert a giant sponge to get rid of any water left behind. And now these new hoses are ready for their baptism by fire. Fish farming generates about 20% of the world's fish production. Some fish farms are very high-tech, while others use more traditional methods. Fish farming began in 2000 BC. If these rainbow trout are going to have the energy to make baby trout, they'll have to be well fed. On today's menu, ground shrimp. The fish farmer gives the mating process a hand. He takes the female fish and presses on her belly to squeeze out her eggs. A 1-pound fish has about 1,000 eggs. It takes about a minute to get them out. Next, he takes the male fish and squeezes out his sperm. This also takes about a minute. The fertilization process is pretty low-tech. No microscopes, no test tubes. The farmer mixes the eggs and sperm by hand. He then rinses the eggs with clean water. He repeats this step 7 or 8 times until the water runs clear. The eggs that stay at the surface are duds, so they're discarded. The farmer transfers the good eggs to bottles, then fills the bottles to the top with water. The eggs incubate for about a month. By the 25-day mark, if an egg is alive, 2 little black dots appear. Fish eyes. After the incubation period, the farmer empties the bottles and spreads the eggs on a surface with slats. The eggs lie here underwater. Until they hatch 10 to 15 days later. The newly hatched trout swim down through the slats into the basin below. The baby trout feed off their placenta for the first 18 days. After that, they eat special trout food made of fish meal. The trout grow to about 8 inches long by the age of 8 months. At that point, the smaller trout swimming around them start looking pretty appetizing. So the farmer has to classify the fish by size and move them into separate basins. Trout reach adulthood at the age of 1.5 years. Now the farmer transfers them into his man-made lake. From here, the fish will go to market. But before they leave, the farmer mates them, starting the cycle all over again. The grain most commonly ground into flour is wheat. Flour mills use high-protein or hard wheat species to make bread flour. and lower protein or soft wheat species to produce cake and pastry flour. All-purpose flour is a compromise with medium protein. As soon as the wheat shipment arrives, a grain probe vacuums up samples from throughout the load. If the samples pass quality inspection, the mill gives the truck the go-ahead to dump the wheat onto an underground conveyor. From there, the grain goes into a cleaning machine, where a system of sieves removes impurities such as straw, sticks, and grain dust. The wheat then goes into storage silos until milling time. The protein content of wheat varies by species, so the first step is to blend together the right varieties of wheat for the type of flour they'll be making. From the blender, the wheat goes through a second, more intensive cleaning system that removes the tiniest of impurities, such as weed seeds and dust. On the way to the milling machines, a scale tracks production quantities. This mill's vertical production line is 5 stories high. Gravity carries the wheat downward through a succession of milling machines. Each one grinds the grain between steel rollers and then sifts it. Particles too large to pass through a sieve continue downward into the next milling machine, and so on. By the time the wheat hits the last machine, anything that's not fully processed gets vacuumed up to the top to begin the cycle again. Mills make white flour by grinding only the wheat kernel's soft inner part, called the endosperm. This requires removing the bran, the kernel's hard skin, and the germ, its seed. That separation begins as soon as the wheat kernels enter the very first milling machine. Rollers break off the germ and bran and crush the endosperm into pieces called semolina. Sifting removes the germ and loose bran pieces, but much of the semolina remains covered in bran particles. So between each milling station is a purifier, a machine that uses controlled air currents to float the lighter bran above the heavier semolina, enabling sieves to separate the two components. The semolina goes through repeated grind, sift, and purify cycles until it's completely clean. Only then can it be finely ground into flour. The ground semolina passes through a series of sieves. This ensures it doesn't leave the final milling machine until it's been ground to the right powdery texture. There are 3 main types of white wheat flour. Bread flour has high protein, enabling dough to rise well and bake to a firm texture. Cake flour has low protein, which produces a crumbly texture. All-purpose flour is the compromise. Its medium protein content makes it suitable for baking both bread and cakes. By the end of production, the flour mill has produced 3 distinct products: bran, used for animal feed and baking; white wheat flour; and wheat germ for the health food market. Leftover byproducts go into livestock feed. In the mill's quality control lab, they bake the product for which the flour is designed and then examine its appearance, texture, and taste. They use specialized equipment to calculate the volume, the density, protein, and moisture contents. With baked goods destined for retail sale, like these cookies, it's especially important to measure the dimensions. If dough overexpands, the cookies won't fit in their package. Just prior to packaging, the mill enriches its white flour with vitamins and minerals. This replaces the vitamins and minerals lost when the milling process removed the bran and germ. They shake the bags to settle the flour. Bagged flour in various sizes goes out to supermarkets, restaurants, and commercial bakeries, while tanker trucks ship bulk flour to large industrial bakeries. Fishing reels date back to 12th century China. In the beginning, they were very basic devices, used only for storing extra line. But by the 1800s, craftsmen in Britain and America reinvented the reel when they gave it a drag system for landing feisty fish. These fly casters could hook the big one at any moment. And that's when a precision fishing reel will come in handy. To make a fly fishing reel, they start with a solid aluminum puck. The puck turns on a lathe as a computerized cutter contours it to shape it into a spool. A different tool machines a center hole. The focus then moves to the other side as another tool completes the spool shape. The dimensions must be exact if this fishing reel is to perform flawlessly. They drill holes to both reduce the weight of the spool and provide some ventilation for wet fishing line. They cut windows into the other side for an attractive look that further lightens the reel. Next, another aluminum puck is transformed into a frame for the spool and other parts. The frame goes into a bath of soapy water and plastic pellets, which rub the part clean. The final touch is a black oxide finish. They now transform this aluminum bar into feet, which will be used to mount the reel to the fishing rod. A laser engraves the company name onto these attachments. It also does a bit of custom engraving on the frame. A worker now inserts a bronze bushing into the center of the spool and uses hydraulic force to entrench it. He then positions a stainless steel ball on top of the bushing. He activates a press that drives the ball through it to expand the bushing to the correct internal dimension. Another worker applies a counterweight to one side of the spool. This bit of stainless steel will offset the weight of the spool handle. She installs the spool's magnetic locking mechanism. This molded polymer part has a tiny magnet inside. She applies a second magnet to it, followed by a release button. One final magnet and an aluminum cap, and this assembly is complete. She now installs part of the drag engagement system. It's this system that will create the necessary resistance on the fishing line for battling a big fish. She applies adhesive to screws and then uses them to attach the footing to the fly reel frame, using a screwdriver to set it to a specific torque. She then resumes the assembly of the drag system by placing a rubber O-ring in the frame's center groove. She installs the thrust bearing ring, which can be rotated by the fly fisher to adjust the drag setting. And it's now time to attach the spool to the fishing reel frame. She turns it to check the drag setting and adjusts it to its starting point. She secures the setting by inserting a pin into the bearing. Then she removes the center locking screw temporarily to assemble the knob base to the thrust bearing. She reinstalls the screw and covers the assembly with the drag knob. She turns the spool for a final inspection, confirming that this fishing reel operates smoothly. And now it's ready to put a positive spin on any fishing experience. To wish condolences, congratulations, or for romance, there's no shortage of occasions for sending flowers. Whether made up in a splendid arrangement or simply placed in a vase, fresh-cut flowers rarely go unappreciated. Roses are a perennial favorite. Florists buy them from commercial greenhouses. Those greenhouses have sophisticated sprinkler systems positioned to irrigate the soil rather than the plants, because watering directly on the rose bushes would grow harmful fungus. The hotter the weather, the more watering is required, up to 7 times daily for about 5 minutes each time. The greenhouse climate is computer controlled. If it gets too humid, the computer automatically triggers the roof to open, bringing down the temperature. The ideal greenhouse temperature for most flowers is about 70 degrees Fahrenheit during the daytime and 60 degrees at night. With every watering, the roses get a low-level dose of fertilizer, the botanical version of taking a daily vitamin supplement. It's a mix of nitrogen, phosphate, and potassium. The proportions are determined by ongoing soil analysis. If the pest specialist detects a bug problem, he applies an insecticide treatment to target the particular pest. But first, they close the roof, so as not to pollute the outside environment. Workers handling the chemicals wear masks and protective clothing. The roses grow through the openings of horizontal trellises, positioned one above the other. This ensures the stems grow tall and straight. Crooked roses, after all, are worthless. Cutting the roses is tricky and prickly. Workers have to wear thick gloves to protect them against the thorns. They cut the stem at a 30 to 45 degree angle, just above the second set of 5 leaves. The cut must be precisely at that spot for a second rose to bloom. About 40 to 55 days later, depending on the season. Growth is slower in winter because there's less sun. The growth period also varies somewhat according to the variety of rose. The fresh-cut roses go into a bucket of lukewarm water with a few drops of bleach to kill off any harmful bacteria. Workers then check each and every rose to make sure the blooms and foliage are free of defects. Then they classify the roses by length. The longer the stem, the more the rose is worth. They make a bundle of each length. Then trim the bottom of the stems to equalize the height. They wrap the roses in newsprint so they won't dry out during shipping. The transport trucks are refrigerated in summer and heated in winter to keep the roses at a safe temperature, about 40 degrees Fahrenheit. To make a bouquet of dried roses, they select open blooms for a nicer look. Then hang them upside down in a room cooled by fans. They leave lots of space between bouquets so the air will better circulate. The roses take a week to dry out. Fresh-cut flowers are striking, whether part of an arrangement or in a vase. They can last in water for about a week, provided you trim ½ inch of the stems to open up the water channels. Fill the vase with lukewarm water, never cold water. Pour in a bit of bleach to ward off stem clogging bacteria. Change the water every 3 days, and be sure to keep the flowers away from the heat of a sunny window.